Good morning, my dear students. Today we will complete the example questions in continuity. See, almost all we finished the questions, exercise problems. So, exam question number 34 in exercise problem, that is, find all the points of discontinuity of f defined by f of x is equal to mod of x minus mod of x plus 1. So here we have to find the function, then we have to discuss the continuity or discontinuity, means find all the points of discontinuity. At how many points the function is discontinuous. So let us take the problem. So solution of problem number 34. So this is also important question. So take the given f of x is equal to mod of x minus mod of x plus 1. So here we have to find the function. So separately let us see, this also is equal to when x is less than minus 1. If x is less than minus 1, mod of x is also minus x. Minus, this is also negative number, so minus of, so x plus 1 it becomes minus of minus, it becomes x plus 1. Okay, it becomes plus here. This is when x is less than minus 1, smaller than minus 1. When x is more, that is more than minus 1. So that is minus 1 less than or equal to x less than 0 I am taking. When x is more than minus 1, this becomes, that is more than minus 1. So less than 0 means minus x. So this is minus x, and more than minus 1 means it becomes plus value, that is minus of x plus 1, minus of x plus 1 only there. Next, when x is more than 0, more than or equal to 0, all will be positive, that is x minus of x minus of x plus 1. So now simplify, this is equal to minus x plus x get cancelled, only 1 is remaining. Here minus x, that is minus 2x minus 1, and here x plus cancelled, here only remaining minus 1. So these are the conditions when x is less than minus 1, when x is more than minus 1 and less than 0, when x is more than or equal to 0. So this is the function f of x. So firstly we have to convert, that means breaking into conditions. When x is smaller than minus 1, f of x is equal to 1. When x is more than minus 1 and less than 0, minus 2x minus 1. When x is more than or equal to 0, f of x value is minus 1. At all these points we have to check the continuity or discontinuity. Firstly, I have to check at x is equal to minus 1. At x is equal to minus 1, what is the f of minus 1? X is equal to minus 1 means f of x value this is minus 2x minus 1. Substitute here minus 2 bracket minus 1 minus 1. So minus into minus plus 2 minus 1, that is 1. So f of minus 1 is equal to 1. Then left hand limit calculated here. LHL. We know how to find out. Limit of f of x as x approaches to minus 1 negative. This is also written as limit of f of minus 1 minus h as h approaches to 0. When x is smaller than minus 1, f of x is equal to 1. So this implies limit of 1 as h approaches to 0 is equal to 1. Then right hand limit find out. RHL. So that is limit of f of x as x approaches to minus 1 positive more than 1. I have to write this number limit of f of minus 1 plus h as h approaches to 0. When h is more than minus 1, f of x is equal to minus 2x minus 1. So this is equal to limit of minus 2 bracket minus 1 plus h minus 1 as h approaches to 0. Substitute the values minus 2 bracket minus 1 plus 0 minus 1. It becomes minus into minus plus 2 minus 1 is equal to 1. We observe what f of x is equal to f of a equal to LHL is equal to RHL. So at x equal to minus 1, f of x is continuous. That means at x equal to minus 1, f of x has no points of discontinuity. Therefore, LHL is equal to RHL. This is equal to what? F of minus 1 is equal to 1. Hence, f is continuous. F is continuous at x is equal to minus 1. Okay, now the case number 2. At x is equal to 0, we have to check the continuity. This means what? That is f of x at x equal to 1. F of x is equal to minus 1. F of x has no points of discontinuity. Hence, we write one more sentence. Hence, at x is equal to minus 1. At x is equal to minus 1. F has no points of discontinuity. No points of discontinuity of F. No points of discontinuity. Okay. Then we are going to the next case. At x is equal to 0. So at x is equal to 0, we have to find out f of 0. F of 0 is equal to what? F of 0 and x is equal to 0. F of x is equal to minus 1. Then we have to find left hand limit, LHL. Left hand limit to find out limit of f of x as x approaches to 0 negative. This is equal to limit of f of 0 minus h as h approaches to 0. This will be limit of as when x is less than 0, f of x value minus 2x minus 1. So we can write minus 2 bracket x is 1, 0 minus h minus 1 as h approaches to 0. Now we have to substitute the limits. This is equal to minus 2 bracket 0 minus 0 minus 1. This is equal to this whole value is 0 minus 1, that is minus 1. When x is When x is less than 0, left hand limit is equal to -1. In the same manner, we have to find right hand limit RHL. So limit of f of x as x approaches to 0 plus, this is equal to limit of f of 0 plus h as h tends to 0. This is equal to limit of, what is the value when x is more than 0? So f of x value is -1. As h tends to 0, this is equal to -1. So here finally we observe what? In this case also, left hand limit is equal to right hand limit is equal to f of 0. Hence, f is continuous and x is equal to 0 also. So this function has no points of discontinuity. So here I am writing, therefore LHL is equal to RHL is equal to f of 0 is equal to -1. F is continuous. F is continuous and x is equal to 0. Hence, at x is equal to 0, f has no points of discontinuity. No points of discontinuity. So this is the answer of this question. So how many points of discontinuity? We don't have any point of discontinuity at x is equal to -1, at x is equal to 0. We can do it here in CET exam, how to solve the same question. Without doing this procedure in CET exam, what is the here? Let us take g of x is equal to mod of x and h of x is equal to mod of x plus 1. Mod x is always continuous everywhere, that means at the domain. So here mod x is continuous, mod of x plus 1 is continuous. Mod of x minus mod of x plus 1. If f is continuous and g is continuous, then f minus g is also continuous. So this function is continuous everywhere. Okay, there is no points of discontinuity of this function f of x equal to mod of x minus mod of x plus 1, like we can see in CET exam. In theory exam, firstly we have to break into cases at -1, at 0, at those values only. At all these values we have to break into cases, means when x is less than -1, f of x is 1, when x is more than -1 and less than 0, -2x minus 1, when x is more than or equal to 0, -1. We have to check at x equal to -1, find out left hand limit, right hand limit. At x equal to 0, we have to check left hand limit, right hand limit. So in all these cases, this is continuous. This is the problem for all of you this one. Next question. See, there are some more examples are there in our textbook. So simple questions are there. Okay, example 1 is important question. So all of you know that this is also for 3 marks or 5 marks question important. Okay, example 1 now I am taking. What is the example 1? Find all the points of discontinuity. Find all the points of discontinuity of the greatest integer function. Greatest integer function is also called step-off function or floor of the function or box sets simply. So we know very well in functions how to be drawn graphs also, greatest integer function graph. Okay, relations and functions we studied this is. Okay, is it a continuous or discontinuous? We have to check. At where we have to at integers only. At integers, generally at integers it is a discontinuous. At non-integral values it is a continuous. Okay, I will show the at integral values. So example 1 here. So let us take function f of x is equal to, given f of x is equal to, given f of x is equal to greatest integer of x. Okay, this is the greatest integer of x. We have to denote like this. We know very well greatest integer of step of 2, box of 2 is equal to 2. Greatest integer of 2.1 is equal to 2. Greatest integer of 1.9 is equal to 1. Greatest integer of minus 2.1 is equal to minus 3. We know all of these numbers how to find out. So always we have to take lower limits of the function. How to check this is, so I have to take one integer and take it. Let x is equal to a, which is an integer at integral functions. Non-integral means that is except integers 1.2, 2.1, 1.9, those are non-1.5, those are called non-integral values. Integral values only 1, 2, 3, 0, minus 1, minus 2, 3 and so on. So we know very well integers. So okay, so let us take here at x is equal to integer. What is the f of a? Find out. F of a is equal to greatest integer of a. This is equal to a. Greatest. So for example, for sake of understanding, a is equal to 2 I am taking. F of 2, greatest integer of 2 is equal to 2. Next thing, we have to calculate left hand limit. Limit of f of x as x approaches to a negative. So it means left hand side, from left hand less than a. This is also I can write limit of great f of a minus h as h tends to 0. This is the conversion method. So converted. Now use function. So substitute here x is equal to a minus h. Limit of greatest integer of a minus h as h approaches to 0. Okay, for sake of understanding, I have to take the integer value. A is equal to 2 I am taking. If I take 2 minus h, what is the greatest integer of 2 minus h? H is a very small quantity. It is a positive number, lies between 0 and 1 only. If h is equal to 0.1, what happens? This becomes greatest integer of 2 minus 0.1, that is 1.9. Greatest integer of 1.9 is equal to what? 1 only. 1 nothing but also this is nothing but 2 minus 1. Clear? 1 is nothing but 2 minus 1. In the same way, what is the greatest integer of a minus h? So greatest integer of a minus h is equal to what? A minus 1. A is what? General value. Any integer. A is any integer. I hope that you understand this point. Now I will find out right hand limit or h here. Limit of f of x as x approaches to a plus. This is equal to, I have to write in conversion. Limit of f of a plus h as x approaches to 0. This equals limit of greatest integer of a plus h as h approaches to 0. Okay, for sake of understanding, once again you take the number 2. Greatest integer of 2 plus h. H value any point, that is small number, 2 point something. That is 2.1 mean. What is the greatest integer of 2.1? That is 2. If you take any small number, that is something is added for 2. 2 point something. Greatest integer of 2 point something is 2. So greatest integer of A plus H, A plus something, that is equal to what? A. I hope that this is also understood. Now you observe that left hand limit, right hand limit value. Both are exist but are not equal. Hence what do you call? This is discontinuous at integers only. So we can write, we observed here, therefore left hand limit not equal to right hand limit, that is equal to f of a. Hence f is discontinuous at x is equal to integer values. At x is equal to a belongs to them. For every integer, we keep in our brain these things. For all integers, greatest integer of x is discontinuous function. Number of points of discontinuity is not defined, undefined. So many numbers are there. In the same manner, at non-integral values, non-integers, f of x is continuous everywhere. Number of points of continuous equal to undefined. So let us take the simply note. So this note is very important. This is our remark. So f of x is equal to greatest integer of x is discontinuous at all integral values. Next one, f of x is equal to greatest integer of x is continuous at all non-integral values. So this method, remember, it is very useful in CET part also. You thorough that this problem is very important for theory level. Theory point of view, it is very important. So you should understand like this. Taking one example also, you can get answer. Okay. Generally, I have written here. This is example one. In the remaining questions already we have done many questions today. So that is only second problem is mod x problem. Mod x is continuous everywhere. And third one is conditions based on there is given. So we can show that very easy all questions here. Okay, note down all of this problem. Now I am going to the mod x problem. Example 2. Okay. Shall I do this one? Okay, take. Next problem. Discuss the continuity of the function f given by f of x is equal to mod of x. At x is equal to 0. So at x equal to 0, we have to break the conditions. So how should I break into conditions? I break at x equal to 0. So when x is less than 0, mod of x is minus x. When x is more than x, that is positive, and more than or equal to also positive number, I took like this. So this is the mod of x definition. Mod x is equal to minus x when x is less than 0, my x when x is more than or equal to 0. Now we have to find out at x equal to 0, what is the f of 0 value. F of 0 is what? Mod of f 0 is x value 0 here, substitute here. Next we have to find out left hand limit at x equal to 0. Limit of f of x approaches to 0 minus. So we can write limit of f of 0 minus h as h approaches to 0. So now substitute in the function that is when x is smaller than 0, that is minus x. So minus of 0 minus h. Substitute here 0, it becomes 0 only. In the same way, we have to find out right hand limit. Limit x tends to 0 plus f of x. So limit of f of 0 plus h as h tends to 0. When x is more than 0, f of x is x. Substitute here 0 plus h. Okay, apply the limit. This is also becomes, this is what? 0. So in all cases, that means left hand limit, right hand limit and f of 0 also equal. Therefore, LHL is equal to RHL is equal to f of 0. Hence, f is continuous at x is equal to 0. So mod x function, it is continuous everywhere. So remember that one. It is also important question. It is continuous everywhere. So greatest integer function, where it is continuous? It is continuous only for non-integral values. Where it is continuous? It is only for integral values. Keep in mind that point. This is example 2 only. Mod x problem, example 2. Completed example 2, mod x question like this. So maximum questions we finished here. The remaining, you can easily do it third, fourth, fifth questions. Shall we do third question? So what is the third problem? Let us see. Question is what? Show that the function f given by f of x is equal to x square, f of x is equal to x square plus 3 when x is not equal to 0, x square plus 3 when x does not equal to 0, and 1 when x is equal to 0. In this case, we need not break the cases left to right like this. Directly do it here. You can do it also, nothing to worry, same concept. So at x equal to 0, what is the f of 0 value already given? 1 is given. So now here I do not find out left to right like this. So directly we do it in exam. Continuity only just. We have to check only continuity concept. Limit only find out. Whenever there is breaking conditions, we have to follow left to right easy. Okay, now limit find out. Limit of f of x as x approaches to 0. That is either more than 0 or less than 0 mean. So what is the f of x value? X square plus 3. So limit of x square plus 3 as x approaches to 0. Apply the limit. 0 square plus 3 is equal to 3. Observe what? Show that what? Show that the function given by here what we have shown that is important. Discontinuous or continuous? F of x is equal to is not continuous at x equal to 0%. In question is not continuous at x is equal to 0. Okay, here we not continue this is. Therefore, limit of f of x as x approaches to 0 is equal to f of 0? No, these are not equal. Therefore, f is not continuous. F is not continuous at x equal to 0. This much enough. Okay, we show that also not a continuous. We proved already not a continuous here. Very simple question this is. But these models we completed already. In exercise, number of questions we finished. We have done that is. Okay, now we are going to question number 4. Discuss the continuity of the function f defined by f of x is equal to x plus 2 when x is less than or equal to 1, x minus 2 when x is more than 1. Okay, have noted analysis. Note down all the problems step by step in your notes. So what is the problem? F of x is equal to x plus 2 when x is less than or equal to 1, x minus 2 when x is more than 1. We have to check at x is equal to 1. F of 1 find out. F of 1 when x is equal to 1, f of x is equal to x plus 2, that is 1 plus 2 is equal to 3. Then next left hand, here breaking conditions are given, so find the left hand limit of f of x as x approaches to 1 negative equals limit of f of conversion, this is 1 minus h as h tends to 0. 1 minus h meaning less than 1. When x is less than 1, f of x is equal to x plus 2. So that is limit of, substitute here 1 minus h plus 2 as h tends to 0. Apply the limit 1 minus 0 plus 2 is equal to 3. Similarly, right hand limit RHL limit of f of x as x approaches to 1 positive equals limit of f of 1 plus h as h tends to 0. 1 plus h, it means more than 1. When x is more than 1, f of x is equal to x minus 2. So limit of 1 plus h minus 2 as h tends to 0. Substitute the limit 1 plus 0 minus 2. 1 minus 2, that is minus 1. We observe what? LHL not equal to RHL. So left hand side it is actually equal to f of 1 but not equal to right hand limit. Hence f is not continuous at x is equal to 1. So we have to discuss only continuity. So it is not a continuous at x is equal to 1. So like maximum questions over. Okay, any question is given, we have to do it like this in continuity. In CET level we need limits concept also little bit required, because with the help of L-hospital we are doing more questions. Next, last 5th question. This is example 4 completed. Okay, this is the example number 4. Next problem, example number 5. Take the example number 5. Given f of x is equal to, see what is the problem given here. Find all the points of discontinuity of the function defined by f of x is equal to x plus 2. Same, almost all that is same, no? X plus 2, 0, okay, even like this. X plus 2 when x is smaller than 1, 0 when x is equal to 1, more than 1, f of x is equal to x minus 2, more than 1 this is. Now we have to check the discontinuity or continuity of f of x at x is equal to 1, because the function is breaking at x equal to 1 only. So when x is equal to 1, already has given in the statement, according to problem, f of 1 is equal to what? 0 here. Then we have to calculate left hand limit at x equal to 1 only. Limit of f of x as x approaches to 1 negative. What is the meaning of 1 negative? Smaller than 1 from the left hand side value. So I should convert without confusion. I have to convert. This is the conversion. Easy. Okay? Free from the difficulty it means. Limit of f of 1 minus h as h tends to 0. Now giving same meaning. 1 minus h meaning what? Smaller than 1. When x is smaller than 1, what is the f of x? X plus 2. So substitute here. Limit of 1 minus h plus 2, okay, as h tends to 0. Now apply the limit 1 minus 0 plus 2. We get 3. This is the left hand side value. In the same manner, we have to find right hand limit also. How to write this is limit of f of x approaches to 1 positive. 1 positive means more than 1. I can change this one, conversion I have to write. Limit of f of 1 plus h as h approaches to 0. Now getting 1 plus h, something is added. Decimal value 0.1. That is lies, h is a small quantity, like it is always positive, lies between 0 and 1. 1 plus h, more than 1. When x is more than 1, f of x is what? X minus 2. This equals limit of 1 plus h minus 2 as h approaches to 0. Substitute the values. 1 plus 0 minus 2. This is minus 1. So, f is what? Observing. All are exist here. Left hand limit exists, right hand limit exists, f of 1 also exists, but are not equal. Hence it is a discontinuity. Therefore, left hand limit not equal to right hand limit is not equal to f of 1. Therefore, f is not continuous. F is not continuous at x is equal to 1. But asking find the points of discontinuity. How many points here? Only 1. Therefore, hence x is equal to 1 is 1 point of discontinuity. 1 point of discontinuity of f. So how many points of discontinuity? There are only 1 point of discontinuity. So like we have to find all points of discontinuity, continuity problems. Any constant function given, directly limit only find out. 1 by x problem given, limit only find out here. Every constant function is a continuous for all real numbers. Every identity function is continuous everywhere. Okay. Reciprocal function is continuous except 0. So many conditions are there. Polynomial functions, we can say here in CET class. These are the problems. So thorough all of you up to this continuity topic. So first three videos are very important. We should clarify the doubts. And in today's class also main questions are given. One is problem number 34 and greatest integer function. It is very important. Okay. Thank you.